non-deaf signers, they were very good at this, and we picked really hard ones, right? So they did get significant improvement from the first repetition to the last, but the condition, whether they could see themselves or whether it was really blurry or blind, it didn't matter. It didn't, seeing themselves didn't improve their articulation. Now our non-signers, they're definitely ceiling, and so it's a little bit different. So here, these guys, this was hard, you guys. Yeah. But what was interesting was that it wasn't the case that the normal vision was actually better. In fact, it was actually worse than visual feedback. Now I have to say, Brittany recently ran this, and we didn't replicate this. We basically got no difference. We didn't get worse performance. We're not quite sure whether it was sort of things that we did to change the task or whatever. But the hypothesis, there's two kind of possible hypotheses about why you might actually be better when you can't see yourself. One is that what signers are relying on is not visual feedback. We have no evidence for that so far. But that they're using somatosensory input. And that's what, so you have this much bigger reliance on somatosensory feedback to monitor your output. And if you're blindfolded or you can't see it, you may attend much more to that type of feedback, which would be helpful. Another possibility is that we've eliminated the conflict between the visual feedback and the model, because those are conflicting visual inputs. And if you don't see those, then we eliminate that. So I come back to this model here. What it suggests is that, we might have somatosensory targets rather than visual targets. And remember I showed you that supramarginal gyrus was the region that was overlapped for all of the signs, the conjunction area for sign production. This is the region that actually also in Greg's model he proposes for the feedback to come together in SMG, supramarginal gyrus. Okay, oops. All right. So what this bit of data tells us is that within the sort of linguistic domain of speech production, there are models that focus on articulatory targets versus perceptual targets. This data is nicely consistent with articulatory gestural models of phonology. And it also suggests that even though these I guess targets, these phonological targets, they may differ for sign and spoken languages. So these having an articulatory target or a perceptual target may be much more specific to speech than to sign. The other thing that this work kind of tells us, and also other work that suggests that you really are not comprehending stuff in the periphery. If you look at models of language comprehension, there tends to be two ways that you can monitor your output. And one is what's called the outer loop or perceptual loop, meaning you hear what you're producing, and you use that to feed into a comprehension system to catch errors. This is in Leyfeld's model, the external loop. There's also an internal loop, but the external loop is based for spoken languages on auditory perception. It suggests that our work suggests that this loop is not universal, and it's not being used to monitor sign output. Basically based on the Russian sign experiment, but also on other experiments that suggest that your hands actually fall outside your visual field. So you can't comprehend your own signing in the way that I can comprehend my own speaking. So if I'm using this visual feedback to catch errors, it's not rich enough. It's not comprehensible. Okay. And then finally, this difference between input-output suggests that the coupling between input and output is different for sign and spoken languages. For spoken languages, it's very much linked together. I hear what I say being produced by my articulators. There's a very strong link between that perception and that production. For sign, we're suggesting that that link is weaker. In part because you don't always see your productions when they move outside the peripheral, and you're not using that information. So the link between output and input may be much tighter for speech than for sign. And we're actually hoping to do some experiments to try to look at that using imaging to sort of see what the coupling is between input and output for sign. In part because you can better easily distinguish perception from production. For speech, if you produce, you hear, right? What you're saying, but we can sort of tease those apart a little bit more in sign than in speech. Okay. So let me go. Any questions about? So where are we? So first let me take questions about the production sensory.
Actually, it's about the phonology part.
Okay, that's all right.
And so I was just thinking about this because we were talking about learning disabilities in one of my previous classes and how some kids with learning disabilities have difficulty separating different phonological parts. And you were talking about how signers are more sensitive between like distinguishing certain signs that morph into other signs. Is there like a similar learning?
You mean for like the categorical perception?
Yeah.
That part?
Is there a similar like impairment in some people who use ASL?
So we don't know is really the answer in terms of looking at the stuff that's been looked at a little bit in terms of phonological disorders. They've been more looking like at motor disorders. So looking at things like maybe Parkinson's or kids who have articulatory problem. I mean, just a case study that you wouldn't expect given what their cognitive abilities are. But the kind of specific phonological impairment, I don't know of anybody who's reported that. I can say, just to tie it to the production and perception, I do have a theory about stuttering. So for spoken language, there's fairly clear evidence that one way that, or one symptom of stuttering is to have a problem with integrating what you're hearing and your production. So this is why delayed auditory feedback can sometimes help stutterers, and it actually makes typical people stutter because you're messing up that link between the production and perception. And neuroimaging studies have shown that for stutterers, like right before they're going to stutter, you see a difference in neural activation compared to non-stutterers within these auditory sensory motor integration regions. Now, if I'm correct about what I've been saying about the relationship between input and output for sign language, we should not see stuttering, or at least that type of stuttering, because it's not linked in the same way as speech output to production. I can easily ignore the visual input. We haven't tried to see whether delayed visual feedback affects sign production, in part because it's difficult to do because people don't have to look, right? So you can't modulate their attention. But just theoretically, the prediction would be that you're not going to see a lot of the same degree of stuttering in signers as in speakers. And there's only anecdotal evidence to kind of support that. That is, it's not reported where you might think it would be. The reports are really a few, and it's not clear that it's stuttering. So, but we don't know. I mean, so at least it doesn't look like there's a wide report of stuttering in signers, but until somebody actually does a real study to find that out.
But there could still be some kind of mismatch between the sensory feedback.
That's right.
But maybe then that's biologically less likely a problem because those two parts, motor and sensory cortex are so close to each other that at least if it's a connectivity issue. I don't actually know much about the stuttering literature, but
yes,
the auditory cortex obviously is farther away from the motor cortex.
Yeah. Well, I tried to think about, because our other hypothesis is that you're just relying a lot more on somatosensory feedback. So how do you test that idea? And we've thought about things like if you kind of remove somatosensory feedback in different ways, but it's tough because, well, I mean, first of all, it's like,
one thing you do, you can vibrate the muscle, which will stimulate the stretch receptors and make your hand appear as if it's in a different place.
Mm.
So if you,
When you say makes your hand appear to what?
no, it's proprioception is very
So it feels like it's in a
it
different place.
feels like it will sort of mess up the length measurements coming out of the muscles, and so it'll make you feel like your hand is in a different place than it actually is. And so they've done like you can look across, you see that it's in the right place, but it feels like
Right, right, so there's, so that would, I'll have to think about that, because I've done things like, put goggles on to shift those prism goggles, so you get different visual feedback. Because it's not, science not visually guided.
Yeah.
So a lot of the work coming out of the motor literature is all on visually guided motion, because that's what people are interested in. But sign that you don't look at your hands,
Yeah.
and there aren't really targets. It's definitely not like reaching. So it would be kind of, so here you would have to like, I guess moving to your target locations on the body or something like that. But that would be interesting.
Can I ask you, to what degree do people differ in the speed of signing? I mean, signing is sort of, you can self-gauge, I mean, you can do that in speech to some degree,
Yeah.
but, you know, you kind of just speak, meaning sign more slowly than,
My sense is that it's about the same kind of variation that you see in speech. So there are, and New Yorkers sign really fast, and Southerners sign slow. I mean, that same kind of, you see those.
yeah, what I mean is that might help with stuttering issues.
Oh,
You know,
oh.
that kind of
Oh, that's a good point.
self-referential way. Well, you know, I'm just gonna sign more slowly and I'm not gonna have.
And it's not going to have
more
as big a problem as
Or
if.
something along those lines.
That's interesting.
If
Well, it
it's
is
the
slower,
timing.
yeah, it is the overall sort of phoneme production. but
Right, right, so
overall
with
it's
signs,
slower
it's-
under normal
yeah.
That's right, that's right. And I mean, which is another reason, right? You're not sequencing all of these
Yeah.
signs. There's still sequencing, but a lot of it is simultaneous. So, this sign is basically, Apple is basically simultaneous location, movement, and handshake. I mean, this sign has a sequence of 2 locations. But a lot of it is simultaneous, so you don't have the same kind of sequencing. And the speed is a little bit different. So, something about that where you could maybe be a slower signer and it's not going to be really weird, whereas a super slow speaker could sound odd and it wouldn't be a good strategy to, So there's even more reasons to think that stuttering is not going to be observed in sign. Okay.
Well, I mean, after what Marty showed last week, I mean, I would make the argument that some of these regions that you see that are more involved in sign language, mostly comprehension, also production in these parietal regions, are actually also somewhat visual regions, and have, because they show phenotypic
Yeah, someone, I mean,
organization, so they're probably both,
Yeah.
right?
Yeah, or even the frontal ones, like some of those frontal ones, you have some phenotypy that are relatively simple stimuli, or the supramarginal gyrus. I don't know exactly where those areas are, but there is one area in there, in the supramarginal gyrus, just right in the very back of it, that is.
So actually the anterior or posterior?
Posterior. Yeah, pretty posterior. Not, pretty close to where
Where our conjunction was?
yeah, where the conjunction was. It's a multi-sensory sensory area. It wasn't in that one.
No, it's this one. That was our
It's
conjunction.
pretty close to there.
Huh.
Yeah, but it's a small area, but it's strongly activated by just a simple, like, structured versus unstructured motion. So it likes structured, more like structured flow field type motion. But it's also multisensory, so you can just drive it with air puffs on the face without,
Well, it makes sense that this would be an area that you would have all of these different types of signing, if it's that kind of multi-sensory, right? That it's not specific to one type of sign or something like
yeah,
that.
it's not. It's definitely more than one sensation, but you can drive it with relatively. I mean, it had been argued to be vestibular cortex because it gets some. It also gets some,
really?
vestibular input, and so it gets visual and vestibular input. But there's also some sensory input there. But maybe like 3 or 4 or 6 small areas there, and I'm not sure.
Well, yeah.
Which one it is, because one time a long time ago with Adam when we were doing those speech that sounds like song, you know, that sort of song. So these you just got these things from books on tape, and then every once in a while you find something that sounds like somebody singing instead of talking, and then you ask musicians to transcribe it or just listen, like, does that one sound like a song instead of speech? That activated something somewhere in there, and so we tried to look, but we didn't test everybody on it. We just tested the atom on it with the flow field thing, and you could see there was like, you know, there was a little bit there for the, you know, song versus speech, and then right over here, not completely overlapping it, there was a separate activation for this multi-sensory visual one. So it could be that there's actually like 5 or 6 little areas jammed in there.
Yeah.
But it is one, I've always worried about it with regard to, it's not that far from A1. You know, as the crow flies, it's pretty close. And so I've always wondered about whether some of the repurposing A1 was actually activating that thing instead, because it's, you know, it's less than a centimeter away from A1.
But these are bilinguals, right? These are zeroing.
These guys are deaf.
These are,
In this particular study, the production study, they were deaf. So it would be interesting to look at, because there is one thing that we know from Murray's work about comparing hearing signers with deaf signers, at least in superior temporal cortex, is you see for deaf signers, that activation when you're observing or comprehending sign goes all the way, maybe not A1, but right up to there.
Close, yeah.
Pretty close. And the hearing signers do not show that extensive anterior activation. And what her hypothesis was that, well, that's kind of preserved or prefers speech, and so or sound. So for the hearing signers, you don't see activation for sign in that region, but for the deaf guys, it can activate that region. Yeah. So I have two. So I'm not sure how you want to do this. We can just take questions and talk about stuff, or I can present stuff on spatial language or stuff on pantomime versus action. Or we can just. I'm very happy to just. If you have questions about things, to just take questions. So I'll move to the end, and you guys can think about what you want to do.
You started a little late, so if you have a section that takes 5 or 10 minutes.
I think probably I could do the back over here. I can do the action stuff. Is the quickest, I think. Anyone who's taking my class will know all of this. All right. Or I don't know, I think it's interesting because it comes back to this. So, this is another domain where sign languages are kind of interesting because signs can look like the actions that they denote, right? So we have this iconicity in signs that you don't have in spoken language. In particular, if you look at these verbs that are often called handling verbs, because it looks like how you handle an object. And they look like pantomime. So here's the ASL sign for scrub, drink. Okay. And of course, the English words scrub and drink have no relationship to their meaning, unlike these signs, right? Now, if you think about what drives pantomime, it's determined by the nature of the object that you're going to interact with. So you're going to pantomime drinking from a straw, differently from drinking from a mug versus drinking from a shot glass, right? So the object that you're manipulating is determining the form of that pantomime, of that gesture. Whereas for sign, what's determining the form of that gesture is the lexical representation, so what the stored phonological representation is. And so you can use this sign drink to talk about drinking from any of these containers. It just means consume liquid, right? So the kind of processes that are involved maybe in retrieving an ASL sign might be different from producing a pantomime. So we've already talked a little bit about the neural areas that we know are involved in sign production, right? So we see Broca's area involved, we see parietal regions involved. But what about pantomime? So what do we know about the neural areas that are engaged when you ask people to just pantomime? So what's been found is this SPL region. in particular left lateralized, seems to be involved in producing pantone. And you just ask people to show me how you use a razor, show me how you use a toothbrush, versus a lower level motoric task, you get SPL activation. All right. So the hypothesis for this study was that if